Hi guys, how are you? Good evening all. Am I audible to everyone?
Yes, sir.
Fine. Thank you very much. Yesterday we have seen the analysis of a simply supported beam by using analytical method. Now we are going to see how to design a beam in a STAT editor. Generally, most of the structural engineers use STAT editor only to develop any structure. Okay, that is how they have to develop. Okay, let us see today. Okay, fine. Let me share my screen. Okay, my screen is visible to all of you.
Yes, sir.
Okay, fine. Today we are going to design the same beam as yesterday one, but the design will be in STAT editor, and we'll do a program, or like you can say a syntax. Okay, generally programs will follow syntax, so that how to design a beam by using syntax we'll see today. And that too we have seen yesterday by using AISA design. Now we are going to see Indian code design, because both the methods will be covered, and both the codes will be covered. That's how I have planned. Okay, if any confusion you have, please feel free to ask
Clear
me.
idea.
Okay, fine. I'm going to create a new structure. Okay, suppose let me take this one name as Indian code practice. Indian code practice beam. Let me take like that. So I'm going to design. I'm going to create a new structure, so that this is all the fresh UI screen you are seeing. Okay. So first of all, give only developing the model will be in the user interface. Remaining everything will be done in editor. Okay. Okay. So I'm going to take the same dimensions as yesterday's beam. So I'm taking first node at origin, that is 0, in the same node at 5 meters the origin in x direction. So the next coordinate will be 500. Just give me a minute, guys. Okay, fine. So I have created two nodes here. You can see first node. This is the second node. So that I am joining these two nodes with a beam feature here available here, so that you can see a beam has been created between the given node. Okay, this is the same dimension as in the yesterday's class. Okay, that is 5 meters of length. Okay, length is 5 meters. So after this, we'll do in the user interface. And one more thing, there is material specification is there in the analytical modeling tab. After one material feature will be there. If you click on the material property, then these dialog boxes will appear here. Okay. I'm going to assign the property as steel. Why I am assigning here itself, I'll tell you. Okay. Uh, I'm just assigning this to the current beam you are seeing here, so that I have assigned steel property to it. Why I am assigning, I'll tell you in the editor. Okay. So up to this only you can do in the user interface method. So obviously the next step I'm going to take editor. Okay, if you are seeing some symbols here, okay, save, open, close, undo, redo, editor, output. Okay, output is not active because we have not designed or we have not analyzed any, so output is not active. There is one down arrow here, you are seeing, right? So you can tick the boxes whatever the feature you want. You can add more features also here. Okay, more commands, whatever you want, you can add it to here. So that's how the easier it will be. So I have added what are the features available or what are the features I'm regularly using. So I have added them in the top of the user interface. So there is paper and pencil icon is there now. That will be the start editor, we can say command file editor. Okay, so if you click on this, it is asking to save the structure or not. So first of all, click on the save structure so that it will open a text box like this. Okay, you are seeing a text box like this. So these are the contents or bookmarks, I can say. Bookmarks are nothing but whatever the important headings are there, it will show on the left side. Stat space, job information, join coordinates, member incidences, define material constants, finish, etc. All these are headings, or I can say main parts of the this program syntax. So stat space. Generally, I am going to design a plain structure. That is why just you can minimize this one. Okay, we are not going to use any contents here. Okay, just you can minimize that one. Stat space. So when we have to use space, you can use 3D structure, or you can use space for a 2D structure when you are designing the structure with z directional loads. Okay, but we sorry, something I'm getting disturbance from someone. Just give me a minute. Clear. Okay. So when we are going to use space, the space will be used for generally a 3D structure, but it can also be used for a 2D structure. The 2D structure is designing to take Z loads, but we are not giving any Z load because we are designing a beam for a gravity loads. Gravity will be nothing but only y directional loads, right? Just give me a minute. Someone Ram is there, is drawing on my screen. Just could you please take off from your side? Okay, fine. Okay, so we are not applying any Z directional loads, or we are not designing any 3D structure. Just we are designing a simple beam. That's why I'm going to take a plane here. Okay, sorry. Whatever you are giving in the stat, all those commands, please give in the capital letters only. Okay, small letters may be acceptable, but if you give in the capital letters, it look like a unique. Okay, that's why I'm telling you. Just whatever you're giving in the stat input editor here, just give them in the capital letters. Small letters also acceptable in some cases. Okay, but okay. So after that, edit job information. Job information means suppose is there any job number, or is there any job size, is there any project name? You can give whatever you want. That is at the entrance of the that is only you can give at the you can say, how you can say, you can give it at the time while you are creating the structure. I'm not giving any job name here. I'll show you how you can give. I'll show you. There is no problem. Okay. So after that, This is the input width 79. This is the default command, nothing but this will be technique with the stat. So in for any structure it looks the same. Okay, input width is 79. It is something related to stat. Okay, we are not doing with any of this one. Okay, so the next thing you are seeing unit meter kilonewton. So unit means, I think all of you know about units. So we are using here metric units, nothing but the length will be in meter and load will be in kilonewtons. So that's how I'm giving unit meter kilonewton. The first, just give me. Okay, who is this Ram? Just mute yourself always while entering into the class, because your voice may cause something disturbance to the others. Okay, please, anyone joining in the session, please join without audio. Okay. Okay, while asking the doubts, you can unmute, but most of the time you have to be mute only. Okay, please, I'm telling you this one. Okay. Okay. The next thing, that is unit meter kilonewton. The first thing will be for length and the next thing will be for load. Okay. After that, there is joint coordinates. Joint coordinates means something you are seeing this 10000. This one indicates the node number. Clear? This one indicates the node number, and these are the coordinates of the node. 000 is the origin. Okay, this is the origin coordinates that will be allocated to first node, and the second node you are seeing 500. Okay, this is 2 means node number 2, and this is 5 means x coordinate 3, y coordinate 0, z coordinate 0. Okay, so these are all about joint coordinates. And the next come to member incidences. Member incidences means this is one indicates beam number 1. Up to nodes it has been completed here. Members means beams. Okay, beams or columns, anything it can take as a member only. So this one means it will allocate a beam number here. One means a beam number, and this one is the beam number 1, which is connected to beam node number 1 and node number 2. Okay, because there are two nodes only, node 1 and node 2 in the joint coordinates. So these the beam is connecting between these two nodes only. So that's why beam number 1 is connecting node 1 and node 2. Clear? And I have assigned a material of steel in the user interface itself, because all these values we know, but it is time taking to give everything. Okay, because we may give some mistake here. Suppose 2.05 into 10 to the power of 5 Newton per mm square, that is elastic modulus value, we know that one, but we are giving it in the meters kilonewton, because whatever you are giving anything, just what are the unit commands before that, please check from your side. It is in meters, unit meter kilonewton. So this 2.05 into 10 to the power of 5 Newton per the elastic modulus, that will be converted to kilonewton per meter square. So that's why it has 2.05 into e power. E power means 10 power. Okay, 10 power 08. Okay, so and the Poisson's ratio, density, alpha, damping ratio, and type steel. What are the strengths? Strength means these are something factors related. I'll show you what are those. I'll show you in the user interface section after this one completed. What are R, Y, and RT? So end defined material. End defined material means we are defining here. We are starting defining the material here, and we are ending this defined material. So material is defined. Okay. After that, there are some constants. Okay, what are the constants? We have to give some. There will be some specifications. There will be some releases. We are going to see in our next classes all these things. You can say beta. beta value, all these things can be written under constant section. So first of all, this material we have defined here, that defined material should be assigned to members here. Okay, anything in the stat, first one we need to define and then we have to assign it to the structure. So we have defined one material here, that is material steel with all the properties listed here. After that, we are assigning those properties to the member. Okay, material steel are, don't confuse this one. I'll put you like this, okay, for your convenience, so that you can see whatever I'm going to write related to this thing. Okay. Material steel all, it has given by default. I can say, suppose I can take material steel for member. MEMB means member. Okay. Member. What is the member number here? Shift B. If you click Shift B, it will show the number of the member. Okay. So beam number, it is 1 here. So material steel member 1. Why it has given all? Because there are no other members. We have assigned the entire material to the entire view. Okay, any members in this section will get, that's why it has given all, but there are no other members, so it will take, we can write it like this also, all and member 1, anything can be, no problem. Okay, after that constants, we have defined material, we have assigned the material. Now I'm going to give the properties. Properties means section dimensions. Okay, section dimensions to the particular section. Okay, for my convenience, because members, what are the thickness? 6 mm, 5 mm, 4 mm, like the thicknesses, and something I can say, how I can say, flanges width will be 200, 300, etc., like that, 200, 250, 280, 300, like that. Depths will be 250, 300, 350, like that only. But while giving in the meters, suppose 5 mm web is there, or otherwise 6 mm web is there. So while giving in the meters, we have to give 0.006, like that. So for my convenience, I'm going to change the units here. Okay, you can change units anywhere in between the program. There is nothing problem will be there. You can change your input units anywhere in the program. So first units we have defined here, meter kilonewton. Up to this section it is valid. Now I'm going to change the units here. For my convenience, we can do it in meters kilonewton also, no problem. Units mms kilonewton. Okay, so the length will be in millimeters and the load will be in kilonewtons, like that I am giving. And after that, I am going to define a property. Okay, a property to the beam. Property means sectional dimensions to the beam. Okay, so I'm going to define the member, member, member property. This is the syntax. Okay, this is the syntax to define any sectional properties. Okay, member property, you can give American, steel, British, anything. Sorry, American, Indian, British, anything you can give. Okay, so I am going to take Indian type. Okay, Indian type member property. So member property Indian. So after this giving member property Indian, how to assign it to the particular beam? So first one, syntax will be the beam number and then type and then properties. Beam number, type and properties. What is the beam number here? 1 space. Okay, type is nothing but welded plate section, that is defined as tapered section in the stat pro. So TAPERED. Okay, tapered. Tapered 1 is nothing but beam number. Tapered is the type of the section. Okay, the next thing, starting depth of the beam and ending depth of the starting depth of the beam. Suppose I can give, suppose let us take 400 is the starting depth, but you have to include top flange thickness and bottom flange thickness always, because it will take the whole depth, okay, complete depth of the section. Suppose if we take depth of the web as 400, and suppose let us take top flange thickness is 10 mm, bottom flange thickness is 10 mm, okay. So 400 plus top thickness 10, bottom thickness 10, so it is going to 420, right, like this, okay. This is the starting depth. And the next property, thickness of the web. Thickness of the web means, suppose let us take 5 mm thickness of the web. Suppose, okay, you can take 6, you can take 8, you can take 10, anything, whatever your company will give, whatever the plates available in your company's inventory, you can give like that, okay. So 426, first 420 is nothing but starting depth of the web. Suppose in the structure user interface, if you click Shift E, you are seeing a green color, you are seeing a blue color here. Green color indicates starting of the beam, blue color indicates ending of the beam. So first 420 is nothing but depth at the starting, this portion, okay. And the next 420, I'm giving the straight beam, okay. So that's why both the depths will be same. This 420 indicates depth at the end of the section, sorry, end of the beam, okay. So start of the beam, depth at the start of beam, thickness of the web, depth at the end of beam, and then next flange thickness, okay. Suppose let us take 200 as flange thickness. We have considered 10 mm thickness of the flange, okay. So this 200 is flange, flange width, this 10 as flange thickness, okay. So start depth, thickness of web, end depth, flange width, thickness of flange. Clear? So this is all about the syntax of giving properties to a particular beam. And then I have given properties. So this is the units command. It is given only for my convenience. If you have easy in writing in meters, you can do it, okay. If you delete this command, you can give it to like meters, 0.420, 0.006, 0.420, 0.200, 0.010, like that also you can give, okay. So I'm changing again units, meter, kilonewtons. Clear? So like that, you can, I have already told you, you can change units anywhere in the program as your wish, okay. So like that, I have changed it to again the default command, unit, meter, kilonewton, as in the same one, as in the first case, I can say, okay. And then we are going to define the supports to the particular beam, okay. Suppose I'm taking off again Shift E. If you click Shift E, it will show you the start and end ups. If you click Shift E again, it will hide. Okay, fine. And next we have to define. Okay, so supports. In this supports, what are the types of supports we have considered for simply supported beam in the previous class? One node is pinned and one node is roller. Suppose let us take, okay. So if I click Shift N, okay, Shift N shows the node numbers here, okay. So 1 indicates first node, 2 indicates second node. So I am giving pinned to the first node, nothing but node number 1 space pinned. Clear? And the node number 2, what is the node number 2? We have to give in a simply supported beam, that is roller. Roller means only FI direction will consider. Only FI direction will consider. So remaining all the things has to be released. There is no FY, sorry, there is no FX, there is no FZ, there are no moments. Clear? So actually for the roller syntax, we have to give command like fixed but Actually, we are giving fixed. 2 is the fixed, but there are some certain releases so that it will be only Fy. What are the releases you have to do? Fx will be released, nothing but there is no Fx. There will be no reaction in Fx direction. Fy should be there, nothing but that is the roller. Roller will be Fy, nothing but only vertical reaction will be there at the roller. So Fy I'm not giving because all these are releases only. Fx, Fz, and remaining 3 moments Mx, My, Mz. All these has been released. Is it clear to everyone? Whatever I'm telling, are you people understanding? Clear?
Yes, sir.
Fine, thank you. So the next thing we have given supports, everything we have given. So I'm going to give the loads. Okay. So whatever you are writing with starting with star asterisk, I can say star symbol, it will be in the commented mode. Commented means it will not run in the analysis. The line will not compile. Clear? The line which you are starting with star symbol. I'm zooming for your convenience. I'm zooming in. Okay. So I have given some stars here. This line is started with star. So you are seeing green color here. Okay. So whatever the line with green color you are seeing here, that will not run in the analysis. Nothing but that will not compile in the program. So because they have given this feature, you can write whatever the notes for your convenience. Okay, something like because I have done with supports here. Next, I think I am going to give loads. Okay, for these loads, I am taking the name with suppose primary loads, because if any other person sees this design, or if any other person analyzes this design, he should not confuse, right? Whatever features, what are these loads, what are the type of these loads he has defined like this, so he should not confuse like that. That's why we have to give some certain notes. Okay, if anyone sees in the future, that's why this feature has been added to the stat. So whatever the line you are starting with asterisk or star symbol, that will not run in the program. You can write whatever you want here, that will not run in the program. It will not come under syntax. Okay, so I have done I'm doing here primary loads, and then what are the primary loads I'm giving? Dead load and live load for a beam, right? So the load 1. Okay, load 1 is nothing but load number 1. Okay, load number 1. What is the load? What is the name of the load number 1? You can take dead load. Clear? Dead load. You can give anything, dead load or DL, anything, whatever you want, you can give, or only dead. You can give anything. Okay, it's your wish. And then what is the most critical part in the dead load? The self weight of the structure. So how do we define self weight? That is the sprite command. Self weight always acts in global y direction. Y minus 1. Minus 1 is nothing but it will act downwards. Y is positive upwards. Gravitational loads are acting downwards. That's why I have given minus 1. Y minus 1. Clear? And then we have given one type of dead load. So additional dead load is there due to, suppose it is taking concrete load. Suppose, okay, it is taking some slab is rested on the on this beam. Okay, so that the concrete or any other dead load, it is there, it will come to the beam. That will be assigned to member load command. Okay, member load, because there are types of loads: member load, nodal load. There are certain types. Okay, so member load is nothing but we are applying load on the member only. Okay, this is member, right? Generally we know this is a beam. STAD will consider it as a member. Okay, So it is a member. For member number, if I click Shift B, it is showing 1. If I suppose I'm taking off node numbers here, Shift N, so it is showing member number 1. So I have to denote 1, and then syntax will be uni gy, suppose -2. I'm giving. Okay. So what is this uni? Uni means, yesterday we have seen uni means uniform force. Okay. Uni, UNI. Uni means uniform force. That is the short form. Okay. Uni. And GY is nothing but global Y direction. Okay. We are designing this beam for gravity loads. That's why it will be acting global Y direction. Negative symbol indicates it is acting downward. And 2 is the load intensity. That is the UDL. I can say 2 is 2 kilonewton per meter UDL. Suppose this is our example, right? So I have taken example as 2 kilonewton per meter additional dead load is coming on the beam. That's how you have to give. So load number 1 is completed. And then if you go to load 2, I have completed dead here. And I'm going to give live. You can give whatever you want. Okay. So no problem. There is nothing with this name. Okay, you can give whatever you want. So the same thing in this dead load, we have defined self weight because self weight comes under dead load only. So there is nothing like that in the live load. So we are going to give directly member load only. So MEMBER member load. You people guys are somewhat confused. I can understand, but why this will be preferable, I'll tell you after the design has been completed. Okay. Don't worry. This method will be very easy if you learn. For the first time, it will be somewhat confused. Whatever the syntaxes we have to use, all these will be somewhat confused. But it will get easy once you practice on your own. Okay, whatever I'm telling you, have to practice by yourself. So please do it so that you can achieve good results, right? So, and the same member, only one beam is available, that is with the number 1. So 1 uni gy, again space, everything you have to give space. Okay, uni means uniform force acting in the global Y direction. Acting minus means negative, means downwards. So suppose let us take as a 3 kilonewton per meter UDL. This is all about giving loads. Okay, I am going to design this beam with live load and dead load and live load only. So I have completed with the loads. What are the next? I think I have told you yesterday. Okay, so we should not design any structure for primary loads. Okay, what do we do? We have to design any structure for combination, load combinations. So that's why I have to give load combinations here. Suppose I can take again comments here. Okay, load combinations. Yesterday we have seen, suppose ASD, American code ASD, we have seen yesterday, right? So we suppose we what are the load we design now according to IS 800 LSD. Okay, so we have to give combinations for IS 800 LSD. Can anyone have idea what are the safety factors available for limit state design according to IS 800 for dead load and live load? Do you have any idea about safety factors or load combination factors?
For 1.5 factor dead load, live load.
Yes, exactly. Perfect. So 1.5 is the safety factor for dead load as well as it is the same for live load. So how to define a load combination case? So I'm going to write load COMB. You can take directly also load combinations. You can mention, but whatever the short, that will be easier. Okay, so I'm going to give load com, and then next what we have given, load, and then the load number, and then that indication what type of load it is. The same thing you have to follow here. Load combination is the type, and load combination number. Suppose I can say 100. 100 is the combination. You can start anywhere. Okay, 1 and 2 are assigned to dead end live. So after that, 3 also you can take here. Okay, no problem. Whatever value you can take, 3 or 30 or 70 or 50, anything you can take after 1 and 2. So I'm taking 100. Okay, load combination 100. You can give a load case number, load case name. Suppose 1.5 dead load plus 1.5 live load. We have given this as a name. Don't confuse. This has a name. It does not know what is 1.5 DL, what is 1.5 L. That we have to assign it now. So we have created a load combination with 100th number with the name of 1.5 dead load and 1.5 live load. So we have to assign partial safety factors for those loads. Okay. So 1.5 dead load. Safety factor is 1.5. That should be multiplied with dead load. What is the dead load number here? Dead load number is 1, right? So 1 space safety factor, that is 1.5. Okay. There are no commas, no inverted quotations, or no semicolons, no colons, etc. Only everything will be in the space only. Okay, all the terms will be separated by using space only. We should not allow. We are not supposed to use semicolons, colons, commas, etc. We are not going to use any special characters at the rate, something anywhere. Okay. So first one will be the primary load number. This one indicates this one. Okay, one is 1 here. Suppose. Okay, so 1 is the load, primary load case number. That is 1 indicates dead load. Dead load number is 1, right? So that's why I have given 1 here. And then space, what is the factor you are going to use in the load combination? So 1.5, because in the limit state method, we have partial safety factor of 1.5 for dead load. And the same thing for load case 2. What is the load case 2 for live load? Okay, what is the factor for live load? That is 1.5. 2 space 1.5. Please be careful. I have not used any commas, any semicolons, etc. here. That's it. Load combination. Okay, and then we have okay. So loads I have given, load combination I have given. So the next thing is we have to perform analysis. I have told you.
Please remove 2. You have written 2 times.
Oh, where? Okay. This one, huh? Oh. This one only?
So yes, sir.
Okay, fine. Yeah. Okay. Safety factor is 1.5 only. Okay. If I do any mistake, please feel free to ask me. Okay. Because I'm typing here, there may be some typing mistakes. Okay. You have to observe carefully. So load combinations I have defined. So the next command is perform analysis. I have told you what is perform analysis in the last class. The same command I'm typing here. I'm typing here. Perform analysis. Perform analysis command. If you give perform analysis only, it will check for bending moment, etc. Everything. Okay. It will calculate the forces, any axial forces, any lateral forces, any vertical forces, etc. Anything it will calculate if you give perform analysis only. Okay, so perform analysis. After that, load list command. Load list. Why we have to give load list? Because we have given some certain loads: load 1, load 2, load 100. We have given 3 types of loads. Stat does not know automatically for which load it have to design for. So we have to give a particular number so that it will be designed for that combination only. So what is the design combination here? It is the only one combination, that is with load number 100. So load list 100. Clear? Load list 100 means it will perform design for 100th load case only. What is the 100th load case? That is load combination. So any structure should be designed to withstand load combination case only. right? That's why I have assigned 100 only here. We should not design for load case 1 or 2. We have to design for 100 only, right? So the next thing, everything I have given according to related to loads. Now the next thing you have to give design. Okay, load part given, analysis part given, design load list I have given. So next, the design parameters I have to give here. So any design parameters will be stored in some particular term, that is parameter 1. Okay, why they have given 1? You can take parameter 2 also. Parameter 2, parameter 3, anything you can take. Whatever the parameters you need, you can give it to parameter 1. Whatever the parameters you don't need, that can give into parameter 2, and you can comment it in the next design if you don't need them. Okay, that's why they have given parameter numbers. Okay, we don't need all these things. Okay, parameter 1 is sufficient for us because we have to give all the necessary comments only. We are not giving any unnecessary design parameters here. In which we cannot avoid any design parameter. Not any parameter 2. We are taking only parameter 1. So in the parameter 1, first thing we have to make code. Which type you are going to use? IS 800. You are seeing, right? Already it is coming here. IS 800 2007 LST, limit state design. Clear? Syntax is clear. Code you have given. And then next, what is the material property yield stress? I have told you yesterday 345,000. This all will be in meters, meters and kilonewtons. All these units will be in meters and kilonewtons, because if you see any unit change in before them, so unit meters and kilonewton is there, right? So after that we have not changed any units. So all these terms should be given in meters and kilonewtons. So 345,000 kilonewton per meter square. That should be assigned to whatever the members shown in the visual edit. Shown in the user interface. Okay, we have given 1 only. So you can take all MEMB 1 in you can take member 1 instead of all. Anything can be acceptable. Okay, if you have much more members, you cannot give 1, 2, 3, 4, 5, so on like that. So you can give all in case of more members. So I have only 1 member, I can give member 1. You can say all also, there will be no problem at all. You can take all also here. And the next parameter, if you have any, all these properties will be given by company. Don't think anything. All these things will be given by your company. What is the ultimate stress of the steel? What is the yield stress of the steel? Everything they will give you. Okay. So I have given ultimate strength of 490 MPa. That is member 1, all, anything you can give. Ultimate stress. And STP. What is the STP command? STP command will be used to give the whether the section is hot rolled section or the section is welded section. So our one is welded section because we are not giving any hot roll section here. Okay, STP2 all or member 1, anything you can give. 1 indicates hot roll, 2 indicates welded plate. Okay, STP2 all. And then beam. What is the beam? Beam 1 all I am giving. What is beam 1? If you give beam with 0 instead of 1, if you give 0, it will design entire beam as 1 part. Okay. If you give beam 1, this beam will 12 part will be checked for design. So if any part in the beam fails in the design, it will show this beam as failing, like that. So safety is our first priority. So I have to check the beam, the result for every 12th part. So this is the maximum parts available in the StatPro. That's why I have to give beam 1 all. Okay. and then track 0. What is the track 0? This is about printing the output in the output. You are seeing right here, stat output, view stat output. So if you want to give everything to the customer, this part it has a bending moment like this part it has a bending moment like this, because it is designing for every 12th part, right? Those are not necessary. Our final aim is to check whether the beam is passing or not. So I'm giving track 0. Nothing, we don't need any detailed output. Okay, we need detailed design, but we don't need detailed output. You can give detailed output also. If you give 2 here, it will give you detailed output. Nothing to worry, nothing. This will not affect design case. Okay, so everything related to sections you have given. And then next, okay, I'm because you don't guys please confuse, that's why I'm taking every section with comments, okay, so that you guys follow clearly. So if every part is completed, that's why I'm putting some stars. If any lines started with star, that will not run in the design, no problem. Okay, and the next one, we need to give design parameters related to the beam. So unsupported lines, or what is unsupported length in the buckling axis in the major direction? LZ. Okay, yesterday someone has asked me in the last minute, I think, okay, what is the difference between global and local axis? So for that, I am taking this beam in the front view section. Okay, this is the beam you are seeing, right? So I'm drawing something. If you cut a beam section like this, okay, if you cut a beam section like this, the section will be, sorry, I have not defined here. Okay, so okay, if you cut a beam section like this, the section will be I section, right? Like this, it will show. If you cut a section like this, it will be like a cross section. This is the section, because this is the length direction. Okay, so if you cut a section, it will show cross section like this. In this one, this is local x-axis. Okay, this is local y-axis, and the length is local z-axis. So this is all about local coordinates. Global coordinates anyway mentioned in the UCS icon, if you see below. This is about global. These are all local. Okay, these all are local, and this is global. So for giving the design parameters related to the particular beam, we follow local axis only. So this is called the major axis. Okay, this is called the minor axis. These two are called generally minor axis. The major axis is this one, z axis. Okay, so let me continue. LZ. So what is the length of the beam in major axis? 5. LZ 5 for which one? We have given LZ 5. You have to give for this member only, right? So MEMB. You can give member also, no problem. I'm giving shortcut only. Okay, MEMB 1. LZ 5 member 1. You can write it in another way also. Okay, because I have not divided this beam into some certain particular parts. Every this is complete single beam. I have not divided into certain parts for every 2 meters or for every 3 meters. I have not divided like this. This is entire beam, right? So instead of LZ, I can use KZ command also here, because I have not divided beam into parts. So that's why I can give KZ kz is nothing but effective length factor. Okay, lz is nothing but length. So what is the effective length factor if you use kz here? That will be 1. I told you yesterday there are no certain effective length factors for beams as of now. Okay, we are not using. So if there is if there is nothing, we can take it as 1, because if 1 is multiplied with anything, the value will be the same, right? If you multiply, suppose this as member length of 5. So suppose 1, this is the length factor, and nominal length is 5 meters. So what is the effective length value? Lz is equal to kz into L, right? So kz, what is the kz value? I'm taking here 1. What is the Lz value here? Directly it will take 5. So 1 into 5, it will be effective length will be 5 in this case. Okay, you can write it down in 2 ways. Either you can mention kz or otherwise, okay, Lz 5 MEMB 1. If you use Lz, you have to define length. If you use kz, you have to use factor. Clear? That is, k indicates factor only, L indicates length only, right? So you can write it as your wish, no problem at all. Okay. The next thing, Lz we have given. The same thing, Ly what we have given in the yesterday program? 0.33. I told you, because suppose if I am designing a joist here. Suppose if I am designing a joist here, can I draw? Yeah. So in our steel structure, the sheeting will be like this. Tentative. I am not a drawing expert. Okay. So the sheeting deck panel, I can say, this will be rested over the joist like this. So all the lower ribs, okay, these are called ribs. Okay. What are the bottom higher and lower part you are seeing? These are called ribs. All the lower ribs will be connected to joist with screws. Okay. You can use this as a Ly, like I told you yesterday. Sorry. Yeah. So that's why I am using Ly as 0.33 for member 1, UNT for top flange 0.33, member 1. For bottom flange also the same thing, or anything. Because I told you yesterday, only the sheeting will be connected to the top flange only. If you click the cross section, yes, suppose I section will be like this. Sheeting will be connected to the top flange only. It will not come up to the bottom flange, right? So we cannot give any support to the bottom flange. So if there is no support, what is the length? Effective length, unbraced length for bottom flange? That will be for full length. So Ly is nothing but unbraced, or I can say unsupported length in the minor axis, unsupported length in the top flange, unsupported length for the bottom flange. Clear? Because I have given these, there are certain screws which will be connected to the joist from the deck panel. Okay, from the deck panel, there will be certain screws connected to the joist. That difference, the spacing between the screws, I have taken as suppose 1 feet. Let us take shortly as 0.33 meters. Okay, so that's why I have given minor axis, because it will give some sort of support to the web. That's why I have taken Ly. It will connect it to top lines only. That's why I have given 0.33 for top line, but it will not affect any thing in the bottom flange. So that's why I have taken unsupported length for the bottom flange is complete length 5 meters, because the screws will not pass up to the bottom flange, right? So that's why I have taken these parameters. So these parameters also I have completed. So we have assigned code, all these things. We have given assigned beam parameters, all these things. Now We have
Sir,
assigned code, but sorry.
Sir, I have doubt, sir.
Yeah, tell me.
Sir, L is it okay? K is it okay? LY 0.33. I am not get it exactly. 0.33 means the
That's
screw
why I told
diameter
you.
or hole in.
No screw diameter. How can you use screw diameter? No. Screw spacing.
No, screw spacing. Every 330 mm. We will provide
Yes,
screws,
that's what I'm taking. Because I'm going to give you an example of joist only here. Okay, there will be a deck panel. Deck panel means, can you understand deck panel? Deck panel means it
yes,
is.
Sir, I know deck panel.
Yes. Okay, someone may not know. That's why I'm telling you. Okay, deck panel is nothing but it is a support sheeting for the concrete laying. Okay, support sheeting for the concrete laying for the mezzanine floor only, for the mezzanine floor or a flat roof structure if you use. Okay, for those only we have to use deck panels. Remaining all will be for roof. Okay, roof panels will be there separately. Suppose roof panels, wall panels. Some maybe flat panels also there. You'll get to know everything if you analyze.
It means the width of the deck sheet 330 mm only. The width of the deck sheet is 330 mm per side like this.
Sorry, width of the deck sheet. No. Width of the deck sheet is not 330. The screw. Suppose I'll draw you again. I'll draw. Okay. I told you the approximate tentative shape will be like this, right? Have you seen anything like this? So screws will be connected to the joist like this. Okay.
Okay.
So
joist mean main beam.
Joist means no secondary beams. Okay. Secondary beams of the mezzanine. Yeah. Between they will run between the joist. I told you in the yesterday's drawing. I'll show you again. This is I'm taking as 330
yesterday class I did not answer.
Oh, that's why. Okay. So I have taken this one as the 330 mm. Okay, fine. I'll show you.
Okay.
What is that? Okay, I'll show
you.
Where is that drawing? Yeah. Okay. This is the mezzanine beam. Okay. This is fixed to the main frame column here. But we are not designing this this beam because it is fixed beam. This is since it is we are entering into the design part slowly so that every people can understand. I'm designing first taking as simply supported beam. These are secondary beams. This is the primary mezzanine beam. This is the secondary beam. So if you observe, this secondary beam will be connected to the web of the primary beam, right? This is the web. This is the length web of the primary beam. So it is connected to the web of the primary beam. Like, okay, where is that? Okay, by using clips, I can say clips. Okay, by using clips, it will be connected to the mezzanine beam. So if you are connecting anything to the web of I section, we have to give pinned connection only because web only takes shear. It will not take moment, right? Moment capacity of web is negligible, right? So if you connect anything related to flange, we can give fixed connection. That's why this is the column flange. It is connected to the column flange. We can fix it. But these joists are connected to the web of the primary mezzanine beam. So we have to design them as simply supported beams. That's why
and I have doubt, sorry. Here in this drawing, it shows the joist is fixing on main beam web. But for example, the plate tuck sheet, the fixing top of the primary beam only, no?
Sorry.
The tuck sheet, the tuck sheet is fixing.
Deck sheeting. No. Who told you the deck sheet will be connected to mezzanine primary beams only? No, it will be transferred to the joists also. They will be connected to the
planche only frame.
Yes, flange only. Yeah, they will be connected to the secondary beams also. That's why I am taking the screw spacing as LY. Okay.
Okay.
And it is not the screws will be connected top flange. But it will give some sort of support to the web, because the web will be connected with the top flange and bottom flange. So if you are connecting top flange with screws, it will give some sort of support to the web also, but it will not provide any sort of support to the bottom flange. That's why I have given bottom flange as fully unsupported, UNB 5. And we have defined all these parameters. I'm not using any KZ here. If you want, you can use KZ, but KZ should be a factor. That should not be length. Okay, LZ is nothing but length, effective length. If you use KZ, that should be a factor. Okay, otherwise you can use KZ also. Mute yourself, someone, please. Just I'm muting you, because so that other people do not suffer. Okay, so you can use KZ1 also here. Okay, if you use like this, you have given LZ as 5, and then next to this you have given KZ as 1. So what it will do, this 5 will be multiplied with 1, and that length will be taken for design. If you use like this, okay, if you give 1.2, suppose this is not our factor, I'm telling you an example. If you use 1.2, or otherwise if you use 1.5, if I save this and close this, what it will do? 5 multiplied by 1.5, because I have defined KZ command next to the LZ command. Okay, previously I have defined LZ. After that, I have used KZ command. So what STAD will do? This 1.5 will be multiplied with 5. This will happen in our cases. So in our beam, it will be 1. So I'm using this as 1 only, because 5 multiplied by 1. So design buckling length of the major axis will be 5. So this is all about beam parameters. And then we have assigned some sort of code here. Sorry, we have given some sort of code here. This code should be assigned to the beam. So check code option is there. Sorry, check code. So if you use check code only, this code will be applied to this beam for design. Okay, check code all, or you can say check code member 1, because we have member 1 only. Only one member is there. We have not used any more members. If you use check code all also, if you use check code member 1, it's your wish completely. Okay, after that, sorry, this is okay, have deleted unnecessary comments. Okay. Check code. After that, generally what we do, generally what we give it to the client, this is the weight of the structure. So what is the weight generally? Weight will be in kgs, right? So we need the weight of any structure in kgs. That's why I'm going to change units here. Units, meter, and load units should be in now kg, right? Clear? Before giving steel takeoff. What is the steel takeoff command? Steel takeoff command is used to give the weight of any member you have defined here. Okay, if you define any member here, that will, if you mention steel takeoff command, this command will help you in giving the weight of the structure. Okay. What we give to the client, we give in tons or kgs. Generally, we give in tons. Structure minimum it will be 1 ton. Sorry, minimum it will be 10, right? So we mention, suppose your structure is 30 tons. We can tell like that customer, right? Your structure is 30 tons. Your structure is 3000 tons. Like that, we'll tell the customer. So there is no tons in the stat. We have maximum of kg. That's why I'm giving units meters kg before doing steel takeoff. So I'm closing this now. So it is showing 3 of the errors. So what I have done. Okay. Okay, sorry.
This parameter is not given in Indian code.
Yes,
That's why it's not
exactly. Yes.
Yeah.
Generally, we do AIC codes. That's why I have
Yeah.
given all these parameters.
Yes, yes.
Generally, these parameters are not given in the Indian code. That's why. Okay. If I delete all those commands, okay, no problem. You can give LX also. Okay, no problem. There is LX command. LX also 0.33. Sorry, remember I had not defined it. You can give LX. That is same as UNT UNB command. You can give LX. What is this again? LX is not there in Indian code. Okay, fine. So all these errors has to be rectified. Okay, I think, okay, this is the start V22 version. Okay, if you use latest version, you will get to know what are the features available in the start. In my laptop, this is the old version. Okay, this is maybe this version is first start connect edition, so that not all the features are included in the start version. Yeah, this version is not supporting all these things. Okay. Just for your information, while designing the structure, I'll tell you what are the parameters I'm using. I'll tell you, don't worry.
In parameters, design parameter is given as per Indian
Sorry?
code.
SSS, tell me.
Design parameter is given in Indian code.
Which one?
If you go through display, there is icon given design, not in input, sir.
Okay. Okay. In this one, you are telling.
Yes. Define parameter. Define
parameters. I think it. Okay, it is not supporting. Probably.
Yes, sir. This parameter is not given in this.
But it is not showing.
Sir, there is a code.
Stat should be updated. My stat should be updated actually.
Yes, stat should be updated.
My stat should be updated. This is the first
even
edition.
Even in updated stat parameter is not updated, sir.
Okay, but actually, if you use working stress method, there will be LX. I think so. My stat should be updated to get the new features. Okay, please use if you have availability of new stat. Okay, so that you'll get to know all the parameters, because this is the starting edition I'm using. Actual office system, it is there in the it is new stat. Okay, so after that, okay, suppose let us say all the parameters has been given. Okay, you have basic idea, right? What is ly, what is lx, what is lz, what is kz, all these things you have basic idea, right? What is stp, what is beam, I can say what is beam, what is prac, or what is fyld, or something, what is fu, all these I told you, right? So you can use by your own. If you have new stat available in your systems, okay, you can use by your own. Just I'm using the features whatever available in my system. Okay, so if you have any doubt while using, please let me know, clarify your doubts. So just all these I have given in the input itself. So if you observe here, the sorry, what are these supports you are seeing right here? The supports have come, and if you click control, okay, the outline of the structure will be like this. So this is like this. If you click control 2, it is like, it shows like a solid. Yes.
Sir, ly.33 is only documents. Any problem?
Sorry?
I think Indian code there is a not separate in top flange and bottom.
Because it is a supported beam, the tension flange, the design in the tension flange, the bottom flange I can say, okay, because it is simply supported beam, the bottom flange unsupported length will not govern in design. But okay, if you take fixed beam, you have to give ly as complete length in this case. Okay, if you are designing a fixed beam, you have to give ly as 5 meters only, because there will be some sort of hogging movement, right? So in that the UNB, in our case, if you use IAC, in the bottom flange also govern. because we are using this, what is this, simply supported beam, it will not in our design. Just in the, so all these things you cannot be doing practice. Okay, why it is like that? If I tell you theoretically, you cannot gain. Okay, if you do practically, suppose I have designed here like this, right? Simply supported beam. You can do fixed beam. Give LYS 0.33, give LYS 5 meters. What is the difference you observe? Okay, just you'll know.
Okay, sir.
Okay, so after the input, everything you have given. So what is the command generally we use for run analysis? You can do run analysis by clicking this button. Otherwise, plus F5, it will run. Just check whether are there any errors, any warnings, any notes, etc. If you are done, okay. So yes, yesterday also I have told you how to check the unity check ratios. Unity check ratios means actual moment, yes, actual moment by calculated moment, actual shear force by calculated shear force. All these will be preparation. It will the unity check ratio, and how much closer the unity, how much unity check for unity check ratio, how much it is closer to one, the section will be that much economical. Okay, if it is far away from one, if it is far away less than one, the section is completely uneconomical. How to check the unity ratio? If you right click on this, there are structures option is there, and if you click design results, if you click structure diagram based on actual ratio, this is unity ratio I call. So if I click OK, what is the unity check ratio here? 0.207 means you can reduce the section, you can reduce the flange width, the flange thickness, or I can say the depth also, like that. Okay, if you give to the if you click on the if you double click the section, there is deflect criteria also. If you check global deflection, what is the dead load, live load deflection, all these things, okay, you'll get to know. There are some certain deflection limits. I'll show you all these limits wherever it is there. I'll show you all these limits. Okay, generally I'm telling you in this class, generally deflection will be, since it is a mezzanine joist, our example is mezzanine joist, this will be checked for 240, 360 for live load, 240 for both dead load and live load. How these will be taken, I'll tell you all these things. Okay, so this is all about by giving input here in the input editor. Okay, all these commands have been given. Just be practice. If you take practice, you'll get to know all these things so that you may not confuse. Okay, so what about the next class? Because I think next week Saturday there is Ugadi, I think Gudi Padwa something some guys follow. So all your people will be available in the next Saturday.
Yeah, I am available.
You can type me in the chat box also. I think you can type me in the chat box so that I'll go like a polling, voting, I can say. Okay, because at least 50% should be attended, because the others might miss the class. Okay, so yes, Ram is available, Ravindra is available, someone Deepak are not available. Okay, so yes, Vegan available, Rajendra available. So maximum of the people available, right? Any others not available? So don't yeah, most of the people available. So I can go with the next class, right? If you don't feel other people because you are not available, you can take the session from the recordings. Are you okay, Deepak? Yes, Deepak is okay to take recordings. Yeah. So remaining people are available. So I'm going to take the next class also in the same time. So have a nice. Sorry, I can take from tomorrow onwards. You'll get into the offices, everything, right? So okay, fine. Okay. So weekend is also over. So take your time to practice after the office or colleges or something, anything. Please practice yourself. And what are the doubts you have? I'll see in the next session. Okay. So thank you for all joining. Okay. Thank you, one and all. Yeah, thank you.